Artificial Intelligence in Forensic Science, Promise, Peril, and Power by Richard Jonathan O. Taduran, Ph.D. Forensic science has always evolved alongside technology. Each generation of investigators inherits new tools that reshape how evidence is examined and how truth is presented in courtrooms. In the 19th century, the microscope allowed scientists to observe traces invisible to the naked eye. In the late 20th century, DNA profiling transformed human identification, turning fragments of biological material into powerful evidence of identity. Today, another technological shift is entering forensic laboratories: artificial intelligence. Unlike earlier tools that primarily enhanced observation, AI increasingly assists with interpretation. Algorithms can compare fingerprints across vast databases, analyze complex DNA mixtures through probabilistic models, or scan hours of surveillance footage in minutes. These systems do not merely magnify evidence, they identify patterns. For forensic science, this represents a subtle but significant transformation. When machines begin assisting interpretation rather than simple observation, the production of forensic knowledge itself begins to change. The question is no longer simply what the evidence shows, but how that conclusion is produced. Why AI appeals to forensic systems. The growing interest in artificial intelligence within forensic science is not difficult to understand. Around the world, forensic laboratories face mounting pressures. Case backlogs continue to grow. Trained specialists are often in short supply, and modern investigations generate unprecedented volumes of digital evidence. Artificial intelligence offers a way to manage this complexity. Machine learning systems can automate many high-volume analytical tasks that once required extensive manual effort. Fingerprint databases containing millions of records can be searched in seconds. Ballistic comparison systems can rapidly evaluate microscopic markings on fired bullets. AI-assisted video analysis can review hours of surveillance footage far more quickly than a human investigator. In DNA analysis, probabilistic genotyping software now assists scientists in interpreting complex mixtures containing genetic material from multiple individuals. These systems apply statistical modeling to evaluate the likelihood that a particular person contributed to the mixture. In such contexts, AI functions less as a replacement for forensic experts and more as a force multiplier. By handling large-scale pattern recognition, algorithms allow scientists to focus on interpretation, validation, and testimony. Artificial intelligence may also promote analytical consistency. Human judgment, while indispensable, is influenced by fatigue, cognitive bias, and subjective interpretation. Algorithms apply the same computational logic every time they analyze a dataset. In principle, this can provide a standardized reference point across laboratories and investigators. For jurisdictions with limited forensic infrastructure, AI may even help extend specialized capabilities beyond major urban laboratories. Software-based tools can support investigators in regional offices, allowing preliminary analyses that once required centralized facilities. In these ways, artificial intelligence offers genuine opportunities to expand forensic capacity. Yet, technological efficiency alone does not guarantee scientific reliability or justice, algorithmic risks, and global inequalities. Yet alongside its promise, artificial intelligence introduces new challenges for forensic science. These challenges are not merely technical, they raise fundamental questions about reliability, transparency, and accountability. One concern involves the data used to train machine learning systems. AI models learn patterns from historical datasets. If those datasets are incomplete or unrepresentative, the resulting algorithms may perform unevenly across different populations. In facial recognition systems, for example, researchers have documented varying error rates depending on demographic representation in the training data. Another issue involves what is often called the black box problem. Many AI tools used in forensic analysis are proprietary systems developed by private companies. The internal workings of these algorithms may be protected as trade secrets. As a result, forensic analysts themselves may not fully understand how a system arrived at a particular output. This raises important legal questions. In a courtroom, scientific evidence must be subject to scrutiny and cross-examination. When an algorithm produces a probabilistic result that cannot be independently examined, the transparency of forensic testimony becomes more complicated. Artificial intelligence also introduces the risk of automation bias. Humans tend to place strong trust in computer-generated results, particularly when they appear in numerical or statistical form. Judges, juries, and even analysts may assign excessive authority to algorithmic outputs. These concerns become even more pronounced when viewed globally. Most forensic AI systems are developed and validated in technologically advanced regions. When such technologies are adopted elsewhere, the datasets used to validate them may not reflect local populations or conditions. In this way, the rapid adoption of AI may inadvertently reproduce existing inequalities in forensic science, particularly between technologically advanced regions and those still developing their forensic infrastructure. Innovation and justice. Artificial intelligence will almost certainly become a permanent feature of forensic science. Its ability to process vast datasets and assist with complex pattern recognition makes it an appealing tool for modern investigations. Yet forensic science occupies a unique position at the intersection of science and justice. Technological innovation must therefore be accompanied by careful scientific validation and legal oversight. Artificial intelligence should remain a decision support tool rather than an unquestioned authority. Human experts must retain responsibility for interpreting evidence, explaining its limitations, and ensuring scientific integrity. As explainable AI and more inclusive datasets advance, the forensic community has tools to mitigate risk while harnessing its benefits. As forensic science enters the age of algorithms, the challenge is not simply adopting new technology. It is ensuring that these tools strengthen the pursuit of truth rather than obscure it. Innovation may reshape the laboratory, but justice must remain the compass guiding every technological advance.